Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3147. Taking maximum energy from the Mystic Dungeon. So this problem is actually very easy. I'm not going to say that this problem is of medium level. This is very easy problem. So let's read the problem statement. In a mystic dungeon, n magicians are standing in a line, right? Each magician has an attribute that gives you energy. Some magicians can give you negative energy, which means taking energy from you, right? So you have been cursed in such a way that after absorbing energy from magician I, you will be instantly transported to the magician I plus k. So k value is given to us, right? So first I, then I plus k, right? This process will be repeated until you reach the magician where I plus k doesn't exist, right? This I plus k index doesn't exist, right? Now, in other words, you will choose a starting point. So this is in our hands, the starting point. So you will choose a starting point and then we have to teleport with k jumps until you reach the end of magician's sequence, absorbing all the energy during the journey, right? You are given an array energy and an integer k. We have to return the maximum possible energy you can gain. Note that when you are reach a magician, right, you must take energy from them, whether it's a positive or negative energy, right? So very easy problem statement. Let's understand with an example here. See here, these are the energies, right? 5, 2, minus 10, minus 5, 1, right? So you can start from this 5, or you can start from this 2, or you can start from minus 10, or you can start from minus 5, or you can start from 1, right? These are the choices we have, right? And k is equal to 3, right? So if I am going to write the indexing here, 0, 1, 2, 3, 4. So if I'm starting from 0, right? If I'm starting from 0, so definitely next time 0 plus 3, next time I have to pick this energy if I'm starting from 0, right? Clear? Done. Now if I start from 1, then definitely next time I have to pick this 4, right? And next time I plus k will be out of loop, right? Clear? Now if I am starting from here, then that's it. There is no I plus k. Same way here, if I start from this 3, that's it. If I start from 4, that's it, right? Clear this part? So I can choose from, I can start from any point, right? And if I'm starting from this, then if I plus k after this index is possible, then we have to choose that, okay, whether it is a positive or negative energy, right? So now let's see how I'm going to solve this problem. Okay, so these are the energies given to us, right? 5, 2, minus 10, minus 5, and 1, right? So here when I am at this point, right, there is no energy before this, right? There is no energy before this which I need to take care, right? So I'm not starting from here, right? If I'm starting from here, then I have to see that whether I have to add this energy with this, or can I start directly from here, right? These are the two choices I have, right? So here if you see, at this particular position, if you see minus 5, right? So here I have two options now. I can start from this point. So if I choose to start from this point, then minus 5 is the energy. But if at this particular index, right, if I thought that let's use this energy as well, right, this green color, this one, right? So if I choose that, then the total energy at this step is going to be 5 plus minus 5, 0, right? So I have two options, right? If I can start from here, or if I start from this value, right? This value is nothing but I can say I minus k, right? I minus k, right? So I is 3, k is 3, so I minus k is nothing but 0, right? 0. So if I start from 0, so from this 0, right, if I choose this, so at this particular position I will make sure that whatever the max benefit I can have, right, max benefit, maximum energy that I can have, I will store that energy only here in the starting. right? So that is why I'm starting from here. If you see, if I'm starting from here, there is no previous point, right? So 5 is the energy, max energy at this particular point. Here 2 is the max energy, there is no I minus k, right? Same way here minus 10, there is no I minus k, right? 0 1 2, so 2 minus 3, right? Minus 1 index, there is nothing, right? Like that, right? That's it. Now here at this particular point we have choice, right? I can choose to start from minus 5, right? This energy, or I can take this energy in consideration. So if I take this energy in consideration, so max among them is 0. So what I will do, I will just update this energy as 0 now. I am going to take the max, right? So at this point, the max benefit is this, right? I need the max energy at every point, right? Now if I see here, we have one, right? So I have two choices. If I can start from this one, or if I start from I minus k. So at I minus k, that simply means at this 2, right? So at this point I have already stored the maximum energy, okay, whatever the best energy at this particular point. So 2 plus 1 3. So these are the two options, right? So here I'm going to update 3 here, right? That's it. So this is done and my loop ends now. Okay, now here after that it is saying we have to return the max energy, right? So here if I start from here, right, if I start from here, then my next jump will be here, right? Then out of bound. If I start from here, then my this is one jump and then out of bound. And if I start from here, then this is one jump, right? Then out of bound, right? That's it. So here if you see, only last three I need to see, right? Last three values, right? Because I can start from here, then I go out of jump, right? I can start from here, then I go out of loop, right? Out of this indexing. I can start from here, I go out of indexing, right? But if I start from here, then also I'm going to reach to this point. I have to, if I start from here now, then I have to reach this point, right? Not this one, right? I have to reach to this point, right? So if I start from here, then definitely I need to reach here, right? So only k is equal to 3, so last three values I need to see, right? So if I start from last three, I go out mode. If I start from any previous value also, then also I will come to these values in the end, right? So and at these values I'm only storing the max energy. So minus 10 0 3, what is max? 3 is max. That's it. 3 is the output, right? Clear? Now here only we have three energies, right? So minus 2, right? 0 1 2. Okay, so here if you see, uh, three energies in total and k is equal to 2, right? So here if I start from here minus 2, right, and then minus 1, so I have first here minus 2 is the only value that I can have. Here minus 3 1 minus 2, right? I minus k, there is no such index, right? 1 minus 2, so here minus is the max energy. At this point we have minus 1, right? And 2 minus 2 is 0, so this is possible. So minus 1, or I can have minus 2 minus 1. So minus 1 and minus 3, so which one is best? So minus 1 is the best, right? So I am going to take minus 1 here. So here I choose to start from this, here I choose to start from this, and here instead of starting from this I choose to start from here itself, right? Because minus 1 is the best energy, right? Now k is equal to 2, so k is equal to 2, right? So here if you see, you can start from here, right? You can start from here, then you go out of bound, right? That's it. So these 2 points, and right, and here if you start from here, then also this is going to be your landing point, right? And then you go out of bound. So only these two are the final landing points, right? So we have to check final two landing points. Among them, which one is max? Minus 1. So minus 1 is the max. We can gain a total energy of minus 1 by starting from addition 2, right? That's it. Clear? Now these are the constants. Energy dot length 1 to 10 to 5, energy of I value minus 1000 to 1000, and k value is less than greater than equal to 1 and less than equal to energy dot length minus 1, right? So very easy problem statement, right? So whatever the values we have, right, first thing I can start from any point, right? I can start from any point, right? And now here let's say this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, right? Now if k value let's say is given to me as 2, right? So I am going to run one loop which is starting from this 2, right? Because k is 2 now. So if I start from this now, so that means that if my I is here, so I minus k is possible, I minus k is going to be possible, right? So k, I'm starting with k itself, so 2 minus I is 2, so 0 is possible, right? So I can start my loop here. Here I will just store the previous energies, minus x minus y, right? Now at this point I will take into consideration whether I need to start from here or whether I need to choose this, whatever the best I have. So these two things I have to check. So this is nothing but like a bottom up approach, right? So if I choose to start from here, then I have to take that, or if I choose to start from here and then add this, because if I start from here now, then I have to add this energy also, right? E, but I have two options, right? E, or if I start from here, then minus x plus e. So among them, which one is best? So I have to choose that, right? Same way here also, I can start from here or whatever the best here, okay? Whatever best here. So that's what I have to choose. Let's say E1, right? Same way here, 4 minus 2. So here, see, now here I can choose to start from here, or here this energy I have to choose, and this energy is already the best of this and this, right? So that is the benefit of this. So I choose start from here, or I can choose start from here. If I'm choosing start from here, definitely I'm taking this into consideration, right? So this into consideration that I may have chosen this in the past, or I may not have chosen this best, right? So whatever the best value is here, I have to choose that, right? So that is the benefit of this. And k is equal to 2 means last 2 points only in the end I have to check, right? Because I can start from here, go out of bound, here start out of bound. But if I start from here, then also I have to make a jump here, final jump. So final jump is going to be go to these two places only, right? So that's it. Let's write the code. Very simple. It's very easy problem, not medium level, very easy, right? So now let's write the code for this one. All right. Let me just maximize the screen. So first thing that you need to do here is to calculate the n value for this energy array, right? Int n is equal to energy dot length, and then after that, this is step one, nothing but bottom up update, right? So here for int I is equal to k and I is less than n, and here I plus plus, and here you are just going to update the energy of I value as math dot max of energy of I value, if you choose to start from this point only, or if you choose to start from energy of I minus k, right? And if you choose to start from energy of I minus k, then you have to add this energy of I as well, because definitely you have to take this jump I plus k, you have to select this as well, right? So whatever the best choice. So this is what how you need to update the energy array, right? And once this is done, then in the end you have to just find out the max. So in the max, just store the integer dot mean value first, all right? And then after that you have to select the last k values, right? And you have to find out the max among them. So int I is equal to last index in the n minus 1, and I can say that my I value should be greater than n, okay, last minus k minus 1, okay? So I should be greater than this, and I minus minus, and here I'm just simply update the max as math dot max of max and energy at this particular index, energy of I. That's it. And in the end I have to simply return max. That's it. That's it. Now let's run the code and see. So see, our solution is empty, right? And let's submit it. And the time complexity for this problem is going to be of n only, right? Here if you see, we are just iterating over n elements, right? And here just last k elements. So n plus k you can say, or n, right? O of n is fine, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.